Last video we introduced the divergence test, which states that if we have a sum of terms in the sequence ak up to infinity, if ak does not tend to 0, then the series must diverge. So an example of how we could use this would be for the infinite sum k equals 0 to infinity of sine pi k over 2 and sine pi k over 2 does not tend to 0, and therefore this does not converge. Okay, so that's how we can use the test. What I also wanted to show was an example of an AK which converges to 0, but where the series doesn't converge. So if we consider the series from k equal to 1 to infinity, and the reason we can't pick 0 is because the series is 1 over k, this is equal to 1 over 1 plus 1 over 2 plus 1/3 plus 1/4 and so on. And as you can see, 1 over k clearly goes to 0 as k goes to infinity. So this, we can't use the divergence test to show this diverges, so we have to do some further investigation to see whether this converges or not. And we can actually group the terms in such a way that we get 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 and so on. And when you group like this, this means that this sequence is greater than or equal to 1/2 1 plus 1/2 plus 1/2 plus 1/2 so on. This is because we can always group the terms, so we get the 1 here, we get the half, this is a half, this is a half, we take the next 8 terms as a half, and so on. And you can keep doing that, and to formally show this, you could, because of this way of grouping parts of the sum into halves, you can write out the partial sums, and then because of this property, you can always find m such that for no matter how far we go in the sequence, we can always find a value so no matter how big we pick m, we can always find some value in the sequence that's bigger than that, and you can prove it formally. But the point is that this sum from k equals 1 to 1 over k does not converge. And if you don't know what I mean about finding some value in the sequence such that we end up greater than m, then be sure to check out the video that I'll link in the cards now on sequences. Last thing we're going to do on a similar vein to that last sequence in this video is the p test. So I want to let p be a real number, then the series from k is equal to 1 to infinity of 1 over k to the p diverges for p less than or equal to 1 and converges if p is greater than 1. Okay, so that's the test, and so all you have to do is look at the value of p. If p is less than or equal to 1, we get a divergent series, and if p is greater than 1, we get a convergent series. That's it for this video. If you do have any questions, be sure to let me know down in the comments. If you are enjoying this series on sequences and series, be sure to subscribe to the channel, and I hope to see you in the next one.